There are 18 members of a club with an executive committee of 3 and a sporting committee of 5. So in part A, we're asked how many different executive committees are possible. So because we're not given the exact members of the committee, we can assume that order does not matter. So effectively, any person can be chosen for either role in that committee. So therefore we calculate the number of combinations from 18 members, where we have 3 distinct people that will be chosen for the executive committee. So effectively the number of members is 18, and the distinct people that can be chosen for the committee we denote R. So we have n factorial on n minus r factorial on r factorial. So that's 18 factorial on 15 factorial by 3 factorial. And you can break this up further. So we have 18 by 17 by 16. And the rest of the terms will cancel with the 15 factorial. And that's divided by 3 factorial, which is 3 by 2 by 1. So 18 on 3 is 6, by 17, by 16 on 2, which is 8. So that gives 816, which is the number of different executive committees that are possible. Now in part B, we're asked how many different sporting committees are possible. So this is the same process as part A. So we have the number of combinations of sporting committees from n equals 18 members, and we have 5 distinct people that can fill the roles of the sporting committee. And note that order doesn't matter again, because we're not given the exact roles in this committee. So I'll leave it for you to calculate this out. And then in part C, we're asked how many different pairs of these committees are possible. So assuming one member can be part of both committees, we have the number of combinations of the executive committee, and we multiply this by the number of combinations of the sporting committees. So note that we're using the multiplication rule here, because we're selecting people for the executive committee, and then we're selecting people for the sporting committee. Now in the next problem, 6 winning numbers are chosen from 45 numbers in the lottery. How many possible winning combinations are there? Well, the number of combinations from 45 numbers, we have 6 distinct numbers being chosen, is n factorial over n minus r factorial, where r is 6, divided by r factorial. So that will be 45 factorial on 39 factorial by 6 factorial, which is 45 by 44, and so on down to 40. And that's divided by 6 factorial. So if you calculate this out, there are 8,145,060 possible winning combinations of 6 numbers.